Okay, our last goal here in 2.1 is to look at some application problems using functions. So the first function that we're going to encounter is the price demand function, which you should definitely spend some time reading about in the textbook, and it already appeared in chapter 1. But here's the price demand function for a company. In this example, it's given by P of x equals 1000 minus 5x, and they specify the restriction or a domain for x between 0 and 100. Okay, and what does x represent here? It's the number of items, and P of x represents the price of the item. It says determine the revenue function and find the revenue generated if 50 items are sold. So the revenue function is going to be one of the most important functions in this class. It's going to be denoted with R of x, and as you'll see on the next slide, revenue is given by price times quantity. That's the magic formula that you need to know. So make sure you put this on an index card or start a sheet of formulas that you're responsible for. That should be one of the top ones. So revenue equals price, which could be obtained from the price demand function, times quantity, which in this example is x, the number of items produced and sold. So R of x equals P of x times x. Well, we know the price demand function. It's 1000 minus 5x. This is our P of x. And we still have to multiply by x. Well, when 50 items are sold, x is equal to 50. So we will just evaluate the revenue function at 50 because that's all they wanted for that problem. So evaluating at 50, we get R of 50. That's just 1000 minus 5 times 50 multiplied by 50, right? That's the times x part. That ends up giving us $37,500. So if 50 items are sold for this business, we're going to make $37,500 revenue. Okay? The domain of the function has already been specified. That was the restriction. X is between 0 and 100. Okay, let's take a look now at break-even and profit-loss analysis. The goal of this class is to really essentially understand when a business makes profit and when it cuts its losses, right? And every business's goal is to always maximize profit and cut losses. So let's start with the three main functions: cost, revenue, and profit. Those are going to be the three main functions in our class. Well, it says any manufacturing company has costs C and revenues R. The costs are what it takes, the money or the amount of money it takes for the company to run its business. The revenues R is the money the business generates. Be careful not to confuse revenue with profit. Those are two different things. Revenue is just the money that's generated from a business. Profit is the money you get to keep, right? It's what you earn after you subtract your costs from your revenues. In other words, after you subtract what it costs to run the business from how much money the business generates. Okay, well, it says the company will have a loss if revenue is less than cost, if the money generated is less than the money it spent to run the business. A company will break even, you guys already know about breaking even, when revenue equals cost, and the company will have a profit if the revenue, the money they generated from the business, is bigger than the money they spent on the business. Okay, now there are two types of costs. We've discussed this already: fixed costs and variable costs. Okay, and those are dependent on the number of items produced, the variable costs. The fixed costs, those are fixed every month. Those are like plant, overhead, etc. So the equation that we saw for total cost in the previous section was C equals A plus BX. X here is the number of items produced. B of X is the variable cost. And really the A here is your fixed costs. Fixed costs. So keeping that in mind, let's take a look at the next slide. The price demand functions, usually determined by financial departments, play an important role in profit loss analysis. Okay, so the function P equals M minus NX is going to be used to describe price demand. X here is the number of items that can be sold at P dollars per item. Okay, and you should really read the textbook because they get into more detail about this price demand function. The revenue function is once again R, the number of items. R equals the number of items sold times the price per item, Well, we could think of this as X times P. X is the number of items sold. P is the price per item. Replacing P with the price demand function, that gives us X times M minus NX. Finally, the profit function, another important function in our class. Profit is just revenue minus cost. It's what you get to keep after you subtracted how much it costs to run the business from how much money your business generates. Okay, so we're not going to worry about this definition just yet. We'll come back to this. You'll see that it's a lot easier to deal with it otherwise. So here is an example of a profit-loss analysis. A company manufactures notebook computers. Its marketing research department has determined that the data is modeled by the following price-demand function. P of x equals 2,000 minus 60x. Whenever x is between 1 and 25 thousands, right? Because x is in thousands here. What is the company's revenue function and what is its domain? So think, we're looking for revenue here, and we need to figure out what the domain for the revenue function will be. Well, the formula for revenue was price times quantity. So what we're going to do is we're going to use our price demand function for price, and our quantity of how much product they make is x. So we need to multiply x times the p of x function. The p of x function was given to be 2,000 minus 60x. So I have x times 2,000 minus 60x, and I get 2,000x minus 60x squared. This is an upside down parabola, right? Notice, upside down parabola if you were to graph it. It's a quadratic equation, and the coefficient of the quadratic term is negative. Revenue is almost always in our class going to be an upside down parabola when you graph it. Okay, so the domain is the only thing left to find. We found the revenue function. Here it is. Well, the domain of the function has to be the same as the domain of the price demand function, which was 1 to 25 in thousands. Why is that the case? That's the case because revenue is calculated as x times p of x, the price demand function. So because the price demand function is a multiple in the rule that gives the revenue function, their domains are the same. So the domain here is also 1 to 25 thousandths. Let's take a look at one more example. We'll look at a profit problem. It says the financial department for the company in the preceding problem has established the following cost function for producing and selling x thousand notebook computers. And the function is 4,000 plus 500x. Okay, x is in $1,000. Write a profit function for producing and selling x thousand notebook computers and indicate the domain of this function. How do we write a profit function again? Well, profit is revenue minus cost. You must remember this. Profit is revenue minus cost. The revenue function we found in the last problem to be 2,000x minus 60x squared. Okay, and they gave us the cost function on the previous slide, 4,000 plus 500x. So putting it all together, we have profit is revenue minus cost, or 2,000x minus 60x squared, subtracting from that 4,000 plus 500x. That's, after simplifying, gives us the profit function. The domain of this function, once again, is the same as the domain of the original price demand function or the domain of the revenue function. And you could graph this on a graphing calculator or using a computer if you like, or even by hand. And once again, notice profit is also an upside down parabola.